Hey folks, how's it going? This is Mr. Murray coming to you with another video in the series of factoring quadratics. And I'm coming to you today with a video specifically on factoring when a is greater than 1. And so basically what I'm going to assert to you in this video is that I have a way that we can factor these kinds of monsters just like we can factor all the rest. And we're going to talk about that. So, just as a recap, factoring is the process of converting from standard form into intercept form. Because now that we've spent some time developing our knowledge of these three forms, standard, vertex, and intercept, and it was really nice having that time, extended time to investigate quadratics, we're now going to start talking, right? We've been talking about changing forms and going from one to another. So now our challenge is, what if we're faced with something like this? So here you can clearly see the difference is that we now have to work with a is greater than 1. So what are we going to do in this situation to turn it into something that looks like this? So previously, up to this point, we've talked about this method called the box method. So what we've done is we learned about this idea that, well, if we want to figure out how to expand a quadratic, okay, what we did was we put one piece on the top and one piece on the side, we filled in the box and we added everything up, and that gave us the area, etc. And so what we did then is we started to talk about factoring, where we did this process in reverse. And the things that we observed that all of the problems had in common, no matter what the answer was that the x squared term is in the top left and the numbers in the bottom right. And figuring out the rest is more or less a puzzle. And I've refused to give you any strategies because, as I've said, they don't always work. And if you have the persistence to work through some common patterns with the box, it's really not that bad. So let's say we were faced with the same kind of problem with the box. Now, my goal is to do the same thing that I would do if a was 1. My goal is that I need to get 4r squared minus 10r minus 24 into this box, and I need to figure out what the length and the width are. That is my ultimate goal. I need to know what's the length and the width, okay? Now, if you think about it, we need to know where some of these things go. Well, where does the numbers always go? The number always goes in the bottom right, and that's not any different, right? Because remember, the only way you're going to multiply two things and get an answer without r, in this case, is if neither of the things has an r in it. Okay, so these are going to just be our numbers. Now, usually this is where the r squared goes. But what do you think is going to be different about this particular situation? Well, we don't have just one r squared. How many r squareds do we have? Well, we have 4 of them. So see, this problem is not very much different than the others. Already it's basically starting out the same. Now our goal is that we need to have 4r squared here and negative 24 here. The only challenge, though, is it's not good to write r and r anymore. It's not good enough because we don't just want r squared, we want 4r squared. So now, not only do we have to think about how we're going to get negative 24, which, by the way, we'll need a positive and a negative since it's a negative, but we're also going to have to think about how we're going to get a positive 4. So we've got to balance both of these things at the same time. Okay, keeping in mind, we also need to make sure that we're multiplying, or rather we're adding these two boxes to negative 10. Now, it's not an easy problem, right? 24 could be 1 and 24. Could be 2 and 12. Could be 3 and 8. Could be 4 and 6. 4 could be 1 and 1 or 2 and 2. So maybe you can look and in your head figure out how this would work. As it turns out, if this was equal to 2 and this was equal to 2, and this was equal to negative 8, and this was equal to negative 3. Positive 3. We need a positive 3. Well, first of all, negative 8 times positive 3 is negative 24. Now, if I put a negative 8 here, well, what's 2r times negative 8? It's negative 16r. And what's 2r times 3? It's positive 6r. And what's negative 16 plus 6? That's 10. So I have 4r squared minus 10r minus 24. So it checks out, and I get 2r minus 8 times 2r plus 3. Now, technically, we can see that these two numbers have a 2 in common, right? 2 goes into 2r, and 2 goes into negative 8. So the way you're really supposed to write this is you're supposed to remove that 2. So I take the 2 out, and then what times 2 would have given me this 8? I remove that 2, and I get a 4. So this is how you're really supposed to write it. Okay? Now, what I'm going to do with this is I'm going to open by talking and doing examples and having you do examples, either with numbers that are prime, A values rather, that are prime, meaning only one in that number can be the combination, but we do want to work up to a variety of combinations. Now, again, I got this correct by chance, but what you have to remember is you just have to have an open mind. You have to be open to the fact that it's going to be a little bit of a process. Maybe you look at it in a positive way and think about it as a fun puzzle you can try to solve. But you also have to be open to the fact that any answer will either be correct, in which case perfect, you're good to go, or will be incorrect, and then think about how can you use that as a way to get to the correct answer. For example, if I had done plus 8 and minus 3, I would have gotten 10r instead of negative 10r, and maybe I could have used that to change the symbols. If I had used 1 and 24, I probably would have gotten a number that was way too low or way too high, and that would have told me that maybe I need to reel it in. Maybe I should go for, I don't know, 3 and 8 or 2 and 12. So if you look at mistakes in a positive way, what's good is that you can quickly change things by just erasing the numbers, and it's not that big of a deal. You just have to take a positive mindset, and any of these problems are solvable. Okay, so now I'm going to move on to another example that I'm going to do using this idea. So I'm essentially just going to do the box. I'm going to walk through some of the logic behind how the box works. And we're going to stick with real simple A values. You can see A is bigger than 1, but you can also see it's equal to 2. And we're going to start real simple and kind of build our way up. So remember, the same principles of the box hold true. Okay, the j squared term always goes in the top left. The 19 always goes in the bottom right. Right? The quadratic thing, the thing with the squared, and the number always go in the same place. Okay? So how could I get j squared? Well, first of all, to get j squared, I would have to have j and j, right? We agree that j times j is j squared. To get the 2, one of the numbers in front has to be a 2, and the other has to be a 1, right? 2 times 1 is 2. J times j is j squared. The trick now is 19. Now the good news is 19 breaks down only one way. 19 and 1. But how you order the numbers is important. So previously I said, look, it doesn't matter where you put the numbers. They're always going to work out. But that was because, as I cautioned you a few times, A was equal to 1. The problem here is that when you plug the numbers in, one of them is going to get multiplied by 2, and the other one is going to get multiplied by 1. So for example, if I put 19 here and 1 here, it's going to look very different than the other way around. And I'll draw both boxes so you can see. So if I do 2j19, 2j, or rather 1j, and 1. Let's see what it looks like. So I get j, 1j times 1 is 1j. This would be 38j. Okay, this again would be 2j squared. This would be 19j, 2j, and 19. So see the difference here is this, you actually get 21j when you add them up. Here, you get 39j. So these are radically different. And again, that's because it's not as simple as multiplying and adding when a is bigger than 1. And the reason is it all comes down to what's going on here. The fact that you're not just multiplying by j, you're multiplying by a number as well that's not 1. And so that makes some of these numbers additionally larger. Okay, so it's some important things that we want to think about. So what we can see is that this is going to be our final answer. So we're going to want to write 2j plus 19, j plus 1. This is our final answer. Okay, but the quadratic factoring experience is just like it's always been. You just got to stick in there with me, believe in me, and you can do this. Okay? Okay, another I do problem. So think about this, right? This could even be a we do. We can figure this out. It's not that much different from the one we just did. Look, what's going to go here, folks? This is going to be our 2n squared. What's going to go here? It's going to be our negative 13, right? Different letters, same idea. How do I get 2n squared? Sorry, 2n squared. This would have to be 2n and this n. How do I get negative 13? Well, there's only one way. Well, I guess you could think about it as two ways. Negative 13 and 1, or 13 and negative 1. But I'm going to choose the negative number because notice that I have negative 11 here that they're supposed to add to. Now, we got to be careful. If I put negative 13 here, when I multiply by 2, right, I get negative 26. That's way too far away. I'm never going to be able to pull it back down to negative 11. So I'm going to put my negative 13 here, and I'm going to put my positive 1 here. And when I do that, negative 13 times n is negative 13n. 2n times 1 is 2n. And I add them, and I get the 11n. So that tells me I have 2n minus 13, n plus 1. So I'm not really, there's no tricks here. It's just simply applying logic and what you already know about numbers. Using positives and negatives and multiplying them to make a negative, and then balancing things out so everything on the diagonal adds up to negative 11. All right. Let's jump in and take a look at this we do problem here. This one's a little bit more complicated. So what am I going to start with first? I'm going to build a box. Okay, good. Now, what can I figure out? What's going to go up in the top left? Up in the top left, what do I write? I write my 3j squared. And then what do I put in the bottom right? 42. Now notice again, we're fortunate, and as I kind of foreshadowed, there's going to be an emphasis around sticking with either small numbers that have multiple sets of factors or prime numbers, right? I want to focus on the ideas. Let's not worry about super complicated a values for now. Let's just take our time and kind of build up some skills, one step at a time. So how am I going to get 3? Well, there's only one way to get 3, right? And what is that? 3 and 1. And now how do I get j squared, rather? J and j. So I need to have a 3j and a 1j, so I get 3j squared. Now I need to find the factors of what? Of 42. So 42 could be 1 and 42. It could be 2 and 21. What's the next biggest number that goes into 42? That would be 3, since 4 plus 2 adds up to 6. and that gives me 14. Okay, 4 doesn't go in, 5 doesn't go in, 6 needs to go in because 3 and 2 go in. So that would be 7, and that should end it. So I've got to do some balancing, right? Because now none of these, notice, add up to 25. What? Why? Because one of the numbers is going to be getting multiplied by 3, right? So it's not that easy as multiplying and adding, because if that's what we were going to do, and look, not everything we're going to come across can be factored. That's a limit of factoring, that it doesn't always work. But if we assume that it does, then our strategy starts to fall a little bit short, right? Because all of a sudden, it doesn't seem like it's going to work. But the reason is because you got to look at what you're multiplying by. One of them is getting multiplied by 3, while the other is getting multiplied by 1. Okay, so that's how this is going to be a little bit trickier. So we need to get an adding up to 25, positive 25. What I notice is 42. If I put it on the 3, I'm way over 25. If I put it on the 1, it doesn't matter. I'm still way over 25. So 1 and 42, probably not it. I'll cross it out so I can still see it and maybe go back to it if some of the others don't work. Then I come across 21. Well, 21's close to 25. I don't want to put it with the 3. If I put the 21 here, I'm way over. If I put the 21 here, if I put the 21 here and the 2 here, I get 42. But then this is 6, and this is 21. So I'm at 27. So close. Okay, it's not bad. So now that I know that I'm close, that's okay. Though I can eliminate it, I get closer to the right answer. So now, based on that, since 2 and 21 were close, what would you check next? 3 and 14 or 6 and 7? Which one makes kind of more sense? You know, you could probably make an argument for either one. So what we have to think about here is how are we going to line this up perfectly? How are we going to make sure that we can get this to exactly work out? And the reality is there's no magic, no silver bullet here. So what ends up I'm going to try is 6 and 7. And if I put the 6 with the 3, I get 18. So that's 18J. And this is 7J. So you'd think to go to 3 and 14, you know what? You could. And maybe that wouldn't work. And you just whittle down the possibilities, because what you know is this. What you know is this. You know that, look, one of the correct combinations is right in front of me. It's just like multiple choice. You know the answer is right in front of you. You just have to figure out which one it is. That's why I love multiple choice, right? Because the answer is looking you in the face. If you set up the combinations, you could make the same argument here. All right. Now I'm going to move on to this one right here. This is another one for us to do. And this one's a little bit more complicated because look at what we're leading with. We're leading with a 4. So remember, we build our box first. And then what's the first 2 things I put in? What goes where first? The 4n squared. And then what goes next? The 45. All right, first I need to find the factors of what? The factors of 4. So those would be either 1 and 4 or 2 and 2. Now I'm going to come to 45. So first I'll write 1 and 45. Then I'll write 3 and 15. 3 is the next biggest number. What's the next biggest number to go into 45? It would be 5 because it ends in a 5 or a 0. It's divisible by 5. So 5 and 9. And that's actually it. 6 doesn't go in because 2 doesn't. 7 won't go in. 7 would be 42 and 49. 8 doesn't go in. And then 9 is matched back with 5. So basically, again, the answer is looking at me right in the face. I also know that to multiply it to a positive, either both numbers are positive or both numbers are negative. We know they both need to be negative because we're adding to a negative number. So how do I get 36? Darn, that's not easy. Well, when in doubt, we could take a guess. So let's try. I like 2n and 2n. See how it works. I'm going to try to put negative 15 and negative 3. Because I notice that negative 15 times 2 is negative 30. So I just happened to get it right on the first try. I tend to say this. If I was going to estimate, I would say a very small percentage of the time 45 is going to work. Okay? Some of the time, the middle numbers, I would say try to stick with the middle numbers. I mean, be prepared to use it. Write it down. Always write the one combo down. Because it does work sometimes, and you know the time that it works is often the time, and you don't get it, is often the time you don't write it down. So just give it a shot there. So I get 2n minus 15, 2n minus 3. All right. So at this point, if you have any concerns or questions or anything about any of this, I really encourage you to go back and rewind and look through things, because in a moment I am going to move on to some problems for you to try. So here's our first problem for you to do. So in this problem, I need to factor 5t squared plus 28t plus 36. That is, I need to turn it into intercept form. So I need you to go ahead, use the strategies we've been talking about, convert to intercept form, and when you're ready, unpause, and I'll show you what I got. All right, so here we go. We're going to start with the box. Now remember, what goes in the top left? 5t squared, and the bottom right, 36. How could we get 5t squared? Well, there's only one way, and it's 5t and t. Or these things flipped around. I like to do the one where you have the number in front of it up top. Just my personal preference. Do it however you want. 36, what are my factors? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay. So I need to multiply to 28, and I know one of these numbers is going to get multiplied by 5 and the other is going to get multiplied by 1. Because they multiply and add to a positive, I also know that I'm looking for these to both be positive. Now what I need to do is let's see, multiply to 28. Let's see, and they're both positive. Add to 28. So I got to think about this, right? So 5 can't get multiplied by any of these because 5 is going to be over, right? If I do 5 times 36, nope. Too much. 18 times 5 is too much. 12 times 5 is more than 28. So basically 5 can't get paired up with any of the numbers on the right, because if it does, will already be over 28, and we know neither of the numbers is negative, right? So nothing's going to be able to pull us back in. Okay, so that's a good sign. Now that means that 5, this can't be it. It can't be this one, because if 5 gets multiplied by 4, right, the other one gets multiplied by 9, that adds up to 29. I like this one right here. Could it be this one? So let's have 5 get multiplied by 3, and then have this one get multiplied by 12. Let's see what happens. I don't know, I'm taking a chance. 15t, 12t, darn. So see, this is only 27. If I reverse it, it's just going to be an overshoot. So you know what? That's okay. It's okay. So it's not it. Whatever. Oh. What if we put an 18 here and a 2 here? And this would be 18, not an 18T, I apologize. Just a straight up 18 and a straight up 2. So that would give me 18T here and 10T here for 28. So see, don't get down in the dumps. You get it wrong, whatever. You cross out another one, you reduced your possibilities, and you try again, right? So we just eliminated. This didn't work because it overshot it. 4/9 didn't work. 4/9 didn't work, rather. 3 and 12, what we thought it was good, it didn't work. So we just go to the next one, and that's all right. Doesn't if you're willing to take the time to really develop that pattern hunting experience and those skills to just really work through it and be persistent, then it's not going to be that bad. Okay? Because a lot of the times when we get down in the dumps, what you don't think about is the time that you spend really kind of like getting upset about it and getting stressed about it and telling yourself you can't is time you could be spending really showing yourself that you can. Okay? Last you do problem. I thought I'd spice this last you do problem up. And so again, this is what we're going to do. The same idea. We're going to pause the video, try to use our notion of how the box works to factor this so it looks something like this, as you see on the right here. Then when you're ready, unpause, and you can see what I got. All right, so remember, first step is we build ourselves a box. Okay, then we're going to put our 9c squared here and our 20 here. And now we're going to have to do some thinking, right? So 9, how do I get 9? Well, that could only be 1 and 9 or 3 and 3. 20, only a couple ways to get 20, 1 and 20, 2 and 10, or 4 and 5. So we're going to have to play around with some numbers, right? So we know that we're looking for 2 negatives, and the reason I know that is because we're multiplying to negative 36, or rather we're adding to negative 36 in the end, and we're multiplying to 20. So a negative times a negative is a positive, and a negative plus a negative is a negative. I also know that the 9 has no impact, because since it's a positive, it won't change what's going on with the signs here, right? Even if I multiply a positive by one of these negatives, still keeps things negative. Okay, so I need to finagle 36 somehow. And I think I know how I'm going to do it. Because I noticed that 3 times 10 is 30, and 3 times 2 is 6. So I'm going to put 3c here, and 3c here. And then I'm going to put minus 10 here, and minus 2 here. And because they're both 3c's, it doesn't matter where you put the other two. Because again, these are literally the exact same thing. So this would give me negative 30c. This would give me negative 6c. So they add up to negative 36. And I get 3c minus 2 and 3c minus 10. So, folks, thank you so much for watching this video. My big takeaway that I hope you walk away from this is this. Factoring these kinds of quadratics. Is it harder? Absolutely. And I'm not going to argue that at all. But can we use the stuff that we've already learned to make it a lot easier? Yes, of course we can. We can use what we know about the box so far to transform this into a problem where we just have to do a little bit more guesswork, a little bit more, puzzling, a little bit more problem solving, but we can get to the answer in the end. Please make sure to check out the activities that I've set up for today's lesson around this. And, folks, keep it up. Stay positive. I'm looking forward to a great hangout session this week. And remember, folks, in the end, don't get down, because you can do it.